Hi all, this is Lakshmi working as assistant professor in the Department of PCE at SNS. So today I'm here to discuss about the lecture series on embedded systems and IoT, and the topic which I'm going to discuss today is about the IoT protocols. The protocol which I'm going to discuss here is all about MQTT. So which is message queuing telemetry transport protocol, and this is a lightweight messaging protocol which is widely used in the IoT, that is Internet of Things. So it basically works on the publish subscribe model. So where which is different from the traditional request response like HTTP. This is different, which follows publish subscribe model. So first, we must understand the challenges faced in IoT communication in order to decide the appropriate protocol which is required for that particular application. So there are a lot of constraints faced when using traditional protocols. So like the first parameter is we have to consider the bandwidth. So the traditional protocols operates in limited bandwidth environment with unreliable connectivity, that is cellular and wireless networks, and also these devices requires the message protocols which is optimized for efficiency and resilience. And the next factor is the power constraint. The battery life of the device is important, and the system scalability has to be considered, whether it is an IoT application will succeed or it fails based on the protocol which we choose. So the challenges faced are bandwidth and the battery life and the network cost, etc. Scalability. So first, let us discuss about the design thinking part of our empathy part, where we understand the stakeholders. So we have to consider the each and every needs of the end user. So here, the user must need a reliable and lightweight communication protocol for IoT. And the bandwidth is limited. Data transfer must be efficient. System should work even with unstable network connection. So here, IoT device developers, the cloud platform architects, the application engineers, and the end users. These are all our stakeholders where we collect multiple feedback and understand their requirements, needs for the designing the protocol. So multiple IoT devices like sensors, activators, and mobile apps, they all need a central broker which manages all the communication points, and the real-time dashboards which displays the incoming data. All these parameters are to be considered while designing a protocol. So here the core problem statement here is that we have to design a scalable, reliable, and efficient message communication for IoT machine-to-machine devices. So the protocol which we are choosing here is MQTT, that is Message Queuing Telemetry Transport Protocol. And this is a lightweight messaging protocol which follows publish subscribe model. And here the publisher will send the data, the subscriber will receive the data, and the broker will act as a central server that manages the messages. So how this protocol works? And so we have already discussed that this is based on publish subscribe architecture with a central broker that delivers messages which is produced from the consumers. So devices will publish the data based on the requirements. So subscribers receive the messages filtered by the topic interest. So this is the core feature of MQTT protocol. So how this MQTT works? So initially the client connects to broker. The device establish a TCP connection to an MQTT broker and subscribe to the topics. So here the client will subscribe to a topic like a channel, and for example, if you are considering the smartphone, the temperature data will be received like that. And next is it publish the message. So another client publishes data to that topic, and the temperature sensors, for example, it will send 25 degrees Celsius to the host. So then the broker will distribute the messages. So broker receive the message and forward it to all the subscribers. And so this is a flow of how this MQTT architecture works. So the sensor will publish the data like temperature data, and the mobile app is the subscriber will receive the data. Then the broker will send data again back to the mobile app. So this is how this type of architecture. So advantages, so as we discussed, it is a lightweight protocol that is very small header, for example, 2 bytes, and it works well on low bandwidth networks. And it has the retimed messages. New subscribers instantly receive the latest value, reliable message delivery, secure data, and it is a lightweight protocol. So now let us sum up the mind map of this MQTT protocol here. So the basics of MQTT we have discussed. The features are it is lightweight protocol. It works based on publish subscribe model, and it runs on the TCP IP port, and the various uh, QoS levels are 0, 1, and 2. That is exactly once, at least once, and at most once. The client serving devices are publishers and subscribers, and it works through a central broker here. And the use cases are the smart home, industrial IoT, vehicle application, and healthcare monitoring. The protocol features are retained messages, persistent session, topic hierarchies, last will, and testament. And it provides security through TLS and SSL encryption process, and authentication and access controls are provided. So this is the overall view of the MQTT protocol. So today's assessment is MQTT employs which messaging pattern? So this relies on publish subscribe model. Which transport protocol use MQTT run over? So it initially establishes TCP connection. Thank you.